Hi, this is Jaden Seal, and today we're going to talk about how to solve quadratic equations by graphing using standard form. To start off, we're going to first talk about what a quadratic even really is, and the word quadratic actually comes from the Latin word quadratus, which means squared, and that's due to its squared variable that you'll usually see in the beginning of the equation. The standard form for a quadratic equation is ax squared plus b squared plus c, which is the way that these equations will be set up in this video. Now, to actually graph an equation that's in standard form, you have to find a vertex first, which would require us to first find the x. To find the x, we have to use the equation x equals negative b over 2a. And after we can get the value of x using this equation, we then plug in x, and that value will be y. This will give us our vertex. Now let's take a look into maybe the simplest quadratic equation, which is y equals x squared. And as you can see, the graph actually doesn't go up in a linear pattern. It's actually raising itself exponentially, which is different from probably what you typically would see in a graph, or at least have seen at this point. And as you can look at the table, you'll see that this graph has something called a 1, 3, 5 pattern, which is actually just saying when x goes up 1 to start off, then y goes up 1, x goes up 1 more, y goes up 3 more, x goes up 1 more, y goes up 5 more. This is actually creating this, I guess with this equation in specific, the fact that you can see that the absolute value of x squared equals y. Alrighty, so let's attempt our first problem. Y equals x squared plus 2x plus 1. Now since we're just starting off with this, let's go ahead and list our a, b, and c values, which a equals 1, b equals 2, and c equals 1. It's also a pretty good idea to list our x formula, negative b over 2a, and now we can get to solving the actual equation. So, since the formula to solve for x is negative b over 2a, b is 2, so that'd be negative 2 over 2 times 1, which is 2. So x equals negative 2 over 2. When that is completely simplified, you just get x equals negative 1. So now we can plug negative 1 back into the equation, and that gives y equals negative 1 squared plus 2 times negative 1 plus 1. When completely simplified, you'll get y equals 1 because negative 1 squared is 1, minus 2 because 2 times negative 1 is negative 2, and plus 1. Now we can just finish off the subtraction and the adding, and we'll get negative 1 equals 1, and then we'll finally end up with y equals 0. So that means our vertex will be negative 1, 0. Alright, so here's the graph to our first equation, and you can see that our vertex is at negative 1, 0. And you can also see the 1, 3, 5 pattern that I was talking about that's expressed in this graph. Now let's go on to our second problem, which is y equals negative 2x squared plus 10x plus 12. Once again, let's go ahead and list our a, b, and c values along with our x equals negative b over 2a formula. So a equals negative 2, b equals 10, and c equals 12. Alright, now to start off, we have negative b over 2a, so we can find x, which would be negative 10 because b is 10, over negative 2 times 2, which is negative 4. So x equals negative 10 over negative 4. And once done, x equals 2.5. So now to plug it back in, we just go y equals negative 2, 2.5x squared, plus 10 times 2.5, plus 12. Whenever we get all our values out, we get y equals negative 12.5 plus 25 plus 12. After that, we can add some of the things together. We get y equals 12.5 plus 12. And then to end, y equals 24.5. So this means our vertex is 2.5, 24.5. So here's the graph to our second equation. You can see that this time I'm in increments of 2 instead of 1. you can see that our vertex is located at 2.5, 24.5. But there's something different about this graph than the last one, and it's that instead of going through a 1, 3, 5 pattern, since A is 2 instead of 1, now we're going through a 2, 6, 10 pattern. And it's basically going to keep that ratio for whatever what A is. So if it was 3, then it'd be a 3, 9, 15 pattern, 4, 4, 12, 20 pattern, and so on and so on. Additionally, you can probably see that this graph, unlike the others, is upside down. And that is due to the negative that is on the A. So whenever you have a negative on your A value, that is going to make your graph go downward instead of upward. Alright, for our final problem, we are going to solve y equals 4x squared plus 15x plus 14. Alright, as always, we're going to list our A, B, and C values, which A equals 4, B equals 15, and C equals 14. We're also going to list our x equals formula, which is x equals negative b over 2a. Now let's start solving. We're going to solve for x. So x equals negative b, which is negative 15 in this case, over 2a, which is 2 times 4, and that's 8. So x equals negative 15 over 8, which is equivalent to x equals negative 1.875. Now, just for this purpose, we're going to go ahead and solve it while it's in fraction form, so you can develop that skill, because that's actually a very good skill to have for these type of equations. So y equals 4, in parentheses, negative 15 over 8 squared, plus 15, in parentheses, negative 15 over 8, plus 14. Alright, and to solve, or to square fractions, rather, what you're just going to do is square the denominator and then square the numerator. So this would end up being y equals 4, then 15, or negative 15 squared is 225, and 8 squared is 64. So y equals 4, parentheses, 225 over 64, minus 225 over 8, because when you multiply fractions, you just either multiply it by the denominator or divide it by, multiply it by the numerator or divide it by the denominator. In this case, I just multiplied it by the numerator, and then 14 just stays the same for now. So we have to multiply the 4 still because it's still there, which would be y equals 900 over 64, because 225 times 4 is 900, minus 225 over 8, and plus 14. Alright, so we can solve this, but not as it is right now. We need a common denominator. So for this purpose, I chose 16 because I saw that everything here could go into 16. So if we want to have a common denominator of 16, and we see that 900 over 64 does not have 16 in the denominator, we have to divide both of these, in this case, by 4, because 64 divided by 4 equals 16. So this now turns into y equals 225 over 16. And now since the 8 is, 16 is 2 times 8, then we have to multiply the numerator and the denominator by 2. So that turns into negative 450 over 16. And then we just have to multiply 14 by 16, since that's our common denominator, and then divide it by 16 at the end. So this whole equation now turns into y equals 225 over 16 minus 450 over 16 plus 224 over 16. So now that we have that, we can go ahead and just do our final addition and subtraction. So we get y equals negative 225 over 16 plus 224 over 16, and add that together, you get y equals negative 1 over 16, and in decimal form, that's y equals negative 0.0625. So our vertex is either negative 15 over 8, negative 1 over 16, or you could also say that our vertex is negative 1.875, negative 0.0625. Alright, so here's our final graph for equation number 3. you can see that this time we're in increments of 4 and that our vertex is pointed at negative 1.875, negative 0.0625. And you can also see once again how this pattern just keeps going in that same ratio. Now it's in 4, 12, 20 pattern. And it's really just going to continue that ratio, like I said, on and on for most quadratics that you see. Although I didn't have to actually make different increments for each graph, the reason I've made different increments is so that you can see clearly that the ratios actually make the graphs look the same. And this is because, just like I said, it's going to follow that same basic 1, 3, 5 pattern in that ratio and above. And you can clearly see it because these graphs look almost identical to each other.